Many of the reagents or chemicals used in the elementary school curriculum can be obtained locally in the drugstore, hardware store, or even the grocery store. So here's an example of a common acid that we use. It's called muriatic acid. It's actually hydrochloric acid. Its concentration is approximately 10 moles per liter. So if you want to make a 1 molar solution, you take 10 mils of this and 90 mils of water and mix the two together to form then a 1 molar solution of hydrochloric acid, which we simply abbreviate with the letters H, capital C, small l, HCl. Another common acid, of course, is vinegar. This is a 5% solution of acetic acid in water. It works for many applications. It's not quite as strong as the muriatic acid, but we can nevertheless use it whenever an experiment calls for an acid. Another acid that is available is sulfuric acid, and it comes commercially in the form of some types of drain cleaners. You will need to check the ingredients to make sure you get the right material. This particular drain cleaner contains almost pure concentrated sulfuric acid, and that has a concentration of 18 moles per liter. You do want to be very careful with it. Even though it's a household chemical, it is still extremely corrosive and can attack your skin and clothing, so you want to make sure you don't work with this carelessly. And that goes for, of course, any of the reagents that you use. Another acid that can be used is a solid compound used in pool treatments to lower the pH of the water. This is known as sodium bisulfate. It's a derivative of sulfuric acid. Sulfuric acid is H2SO4. Sodium bisulfate is NaHSO4. So one of the hydrogens has been replaced by a sodium. So this is a solid, and you can often mix this with a powder and then add water to that to get then the reaction. A common base is household ammonia. This is a solution of ammonia gas in water. If the top is left off, the ammonia will gradually evaporate, vaporize from the solution, and your solution becomes less concentrated. This is a great base, and it can be used for many of the experiments involving a strong base. Another base is drain cleaner. Drain cleaner contains sodium hydroxide as the principal ingredient, along with small amounts of aluminum metal often. In many cases, you can separate the pellets of sodium hydroxide from the aluminum metal to make a relatively pure solution of sodium hydroxide. To make a 1 molar solution of sodium hydroxide, you need approximately 4 grams of sodium hydroxide pellets dissolved in 100 milliliters of water. And that gives you a 1 molar solution. Another source of sodium hydroxide is lye. This particular brand contains a minimum of 98.5% sodium hydroxide. It does not have the aluminum particles in with it. So this is actually a good size to use in the elementary school, and it avoids also having to separate the metal particles from the sodium hydroxide pellets. Another base is calcium hydroxide, often referred to as lime. It's a reagent that is used for the treatment of septic systems. Another base that is used is sodium carbonate or washing soda. We put the washing soda in a plastic container because it slowly loses its water if you keep it in a box. So this is sodium carbonate available in the detergent section of the grocery store. Also a relatively strong base. Another reagent that's widely used is sodium bicarbonate, or baking soda. And it's available in different size packages. We use that for many of the demonstrations. And so it's important to have some of that on hand. Sodium chloride, or common table salt, is another important reagent. Now this is known as pickling salt. Pickling salt is really a purified form of sodium chloride. Table salt has impurities in it to make the salt free running. This has larger crystals and is a purer form, and so I would recommend that you use the pickling salt. Again, we just put it into a bottle to make it more convenient for dispensing. Another compound that is available in the drugstore are Epsom salts. Magnesium sulfate, and it has actually 7 H2O or water molecules associated with this. So this is a great compound for making crystals. And so that will also show up in some of the demonstrations. Here's a commercial product that contains copper sulfate as a principal ingredient. This is known as root clear, used for killing roots that may be penetrating drains. So if you open that up a minute, pour a little bit into here, and you can see that it's a blue crystal. So we have blue crystals of copper sulfate, and when you dissolve this in water, it will form a blue colored solution. It's also great for making copper sulfate crystals from a supersaturated solution of copper sulfate. It gives some beautiful crystals of copper sulfate.